In this video, we are going to analyze how we can simulate the metamaterial absorbers in CST. So I'm going to consider this structure where D is the periodicity, L and M are the dimension of the loop. Here you can see that when imaginary part of the permittivity means the loss in the dielectric, and if the loss in the dielectric is 0, you can see this red curve. This shows that there is no absorption, everything is reflected back. And if the loss is getting increased, you can see that the absorption is happening. That means the dielectric loss is the main parameter which is giving the absorption properties in metamaterial absorbers. So in these simulations, we are going to see what will happen if you are going to use FR4 substrate, which is loss free and loss with loss. And I will also show you how you can generate these type of plots like surface current and power loss densities. Let's see. So today I'm going to use the time domain solver for the unit cell simulation. So I started the CST periodic structures, then I'm going for the unit cell, then phase reflection diagram, time domain simulations, and make sure that the units are okay. Then the frequency I'm going to consider is from 4 to 7. Then click finish. So first I'm going to create the substrate structure. So go for creating the substrate structure. So substrate has a periodicity of 12. So I'm going to put D as the parameters for the substrate. Sorry, and it is the thickness. So I'm going to first put FR4 without loss and without. Okay, so let's see for FR4 loss free. So first I'm going to consider the loss free structure. Then click OK. T is 12 and height of the substrate FR4 is 0.8 mm. So I have created this one. So I have to create a loop. So I will take L as the dimension and create the loop above this substrate. So I'm taking 0.35 mm as the thickness of the loop. Yes, okay. Then click OK. L is 8. And next is I have to take the inner loops. Okay. And is taken as 7. So next I have to create the loop from these two squares. So I'm going to subtract them. So now I get the structure which I'm going to simulate. Now next is you have to put the boundaries. As I'm going to use the time domain simulations, you can put the boundary electric and magnetic. As it is a four-fold symmetric structure, you can put electric on X side or electric on the Y side. It doesn't matter. And this structure is backed by the metal. You can use electric on the Z minimum. And Z max is open add space. So we have to put a waveguide port here. So now we have modeled a waveguide structure where we are putting the structure inside that. Then click OK. Then our next step is to put the waveguide port, and we have to put the waveguide port along Z direction, this direction. So I'm going to click Z. So I have to put the port directing along the negative axis, put as negative. And what I have to do is I have to de-embed the port to this distance. So this distance shows the distance from this point to the waveguide port. So to get the distance from here to here, what I have to do is I have to take the total distance minus thickness of the substrate minus thickness of the loop. So what I'm going to do is I'm going to take this value and I'm going to subtract the thickness of the substrate and thickness of the loop, that is the PC, from this structure. So when I do this, you can see that these portions will be de-embedded onto the structure. So here you can see that it is getting de-embedded to that structure. Why we are doing this de-embedding is because we are only interested in the phase and the reflection from this structure, from the surface of the structure. That's why we are doing this de-embedding. Then click OK. If you don't do the de-embedding, the result will be varying. So it is very important to always use the de-embedding here. Next is you have to just take the mesh, check the mesh. So you can either increase the mesh size here. Instead of 10, you can go for 15. So it will improve the accuracy. Next, I'm going for the simulation. Okay, so I just, because I have put only one mode, so every settings are okay, I'm going to start the simulation. So you have to remember that I have used a lossless FR4 substrate. So we have to check whether the structure is providing absorption or not. Okay, it's produced the result. So I'm going to check the S11. Here you can see that the S parameter is, that is the reflection is showing around 0 value. This means that there is no absorption or everything is getting reflected. So if you see the phase, you can see that it is showing an AMC like characteristics. That means if you see here, you can see that it is showing an AMC characteristics at 5.8. That is the reflection phase is becoming 0 at 5.85. That means this structure is behaving as an artificial magnetic conductor when we are using a lossless substrate. Next, we can change the substrate to like low CFR4. So I'm going to change the material. So instead of FR4 loss free, I'm going to change that to FR4 with loss. For lossy, here you can see that electric tan delta is 0.025. In case of loss free, there is no tan delta, that is there is no loss. In case of lossy, you can see it has a loss. So put that thing, then delete current result and just do the simulations. You can check the port de-embedding and just do the simulation. So we know that for the metamaterial structures, the dielectric loss is the main parameters which is contributing for the absorption. So with this dielectric loss, we have to get some absorption if it is acting as an absorber. Let's see how it is. Okay, it's getting generated. So now we have the S parameter. Here you can see that whatever the frequency we have used seen as the AMC characteristics, we are seeing the absorption here. So you can see that the structure is acting as an absorber when we put the lossy dielectric. If the dielectric is lossless, it will act as an artificial magnetic conductor. If it is lossy, it will perform as an absorber. So next thing is, so if you see the phase, you can see that how the phase response is also changed. Here you can see the absorptive characteristics. Next, we have to do some simulations to see like surface current and power loss. For that, you can go to the field monitors and click here. Okay, let's see what is the frequency 5.83. So we have to analyze the surface current and power loss at the frequency of 5.83. So you can go to the field monitor. So now I'm going to do the field monitor setting. Go for new field monitor. Then this is the power loss density. So I have to simulate for the 5.83 gigahertz, set that frequency, and in use subvolume, you can use structure bounding box. Then it will be simulated only for the structure. Otherwise, it will be calculating for the entire domain. So you can use the structure bounding box. Then click apply. Then it will be getting created. Next, I'll be interested in the surface current. And click apply. If you are interested in the electric field, you can also do that. Then okay, cancel as I have created both these things. Then click start simulation. So it is getting simulated. So the simulation is complete now. We can check the result in 2D 3D result. Go for the power loss density loss. You can see the loss distribution. So as I don't have to see these bounding box, I'm unchecking that, and I I am only interested in the power loss here. So you can see the power loss. If you want to change the settings here, you can either drag like this, or you can go for 2D 3D plots and set the values here. So if you want to have a good plot, you can set this value very less power, so it will produce very good result. Oh, sorry. combination of blue, that means very low power, and red means very high power. Here you can see that the power is mainly concentrated in the dielectric. If you want to see that, you can go for the field on plane, then it will activate the cutting planes, so you can move like this and see how it is implemented inside the dielectric. So my interest is along the z axis, so you can cut along, because we know that the thickness of the substrate is 0.8. So if you want to see inside the dielectric, I'm taking the half of that value. So here you can see that power loss is happening inside the dielectric. That is because of the dielectric loss, the structure is acting as the absorber. Next thing is, if you want to see the electric field, you can use the same parameters. And if you want to see the electric field on the copper plane, you can use thickness of the substrate is 0.8, and the thickness of the piece is 0.035. So you can use 0.835. So it will show the electric field here. So if you want to use that for some plot in the reports, you can always go for the front and you can adjust these values, so you can get a nice plot. So this, from this plot, you can see how the distribution is given inside the dielectric. So next will be the surface current. So we will be interested on the surface current on the patches and on the grounded dielectric. So here also you can drag this thing to get a better view. And you can also do the same like field on the plane and cutting plane to get the field distribution on the patch and on the ground. Here you can see that field distribution on the patch, and if you drag this thing, you will get the field distribution on the ground. So this is how you can use the CST to get the surface current, electric field, and power loss distributions. Thank you.